Remote sensing enables modeling of groundwater pollution risk. Groundwater is the primary source of drinking water for 2 billion people around the world. In the United States, over 40% of public water is derived from groundwater. This water services over 74 million people's homes. There is increased attention directed towards groundwater pollution because nitrate and pesticide levels found in groundwater are above national health standards. Health issues are arising as a result of the contaminated drinking water, and there is increased pressure on public agencies to maintain water quality. We need to make sure this is possible for public agencies with the limited resources they have. The drastic model was developed by the Environmental Protection Agency. It provides an inexpensive method to identify areas that need more investigation. This model provides one approach to evaluate an area based on already known conditions without having to gather additional site-specific pollution data. A numerical pollution potential index is calculated for each grid cell or layer using weights and ratings that reflect the importance of each variable in determining groundwater pollution risk. GIS is a system of hardware and software used for storage, retrieval, mapping, and analysis of geographic data. The DRAS-TIC model is implemented by overlapping layers in GIS gridded maps that portray 7 factors. The 7 factors are depth to water, recharge, aquifer geology, soil texture, topographic slope, impact of the vadose zone, and conductivity of the aquifer. This model involves obtaining and combining maps of areas that affect the transport of contaminants from the surface to groundwater. It then reassigns the index value to those layered maps. The results are a spatially oriented vulnerability index. In this study, land use derived from remote sensing was added as an 8th layer to the map. The reason this is important is because a shortcoming of the DRAS-TIC model is that it does not account for the influence land has on groundwater pollution. Areas with intensive row crops are especially vulnerable since irrigation and water transports pesticides and harmful nutrients back into the groundwater. York County, Nebraska was studied because 45% of the land in York County is used to grow irrigated corn and is at high risk of groundwater contamination. Ratings and weights were assigned for each DRAS-TIC factor as well as land cover. The land cover ratings were determined by the average amount of nitrogen fertilizer typically applied to various crop types. Then, the weighted linear combination of the 7 values were calculated to discover the index of pollution potential. A classification of land use and land cover was done using images from Landsat Enhanced Thematic Mapper Plus of York County, Nebraska. Circular areas and rectangular areas represent agricultural field patterns, which represent diverse crop types, each with differing levels of risk. The agricultural fields predominate across the map and the urbanized areas appear gray. For York County, Nebraska, irrigation status and land cover were mapped at 30 meters spatial resolution using Landsat 7 Enhanced Thematic Mapper Plus. The resolution of the image and the image's temporal availability makes this data an appropriate choice. 3 dates of imagery were selected during the growing season of May to September and used in a hybrid classification using both supervised and unsupervised methods. Field data from the United States Farm Service Agency were used to assess accuracy in classification. The overall accuracy in mapping was determined to be 82.7%. Data for each of the 7 DRAS-TIC factors plus remote sensing derived land cover were reclassified. Land cover ratings were determined by the average amount of nitrogen fertilizer typically applied to various crop types. The DRAS-TIC Pollution Potential Index was calculated both with and without consideration of land use. Index values above 5 were mapped. Areas that exceeded the national health standard of greater than 10 parts per million nitrate nitrogen were identified from 237 water wells. When land cover was used to compute the DRAS-TIC index, the area predicted to be at risk was better associated to regions that are known to have a high nitrate contamination. York County was predicted to be at higher risk for groundwater pollution when land use was considered than when it was not considered. Models such as the DRAS-TIC model, when combined to include land use, can be extremely helpful in targeting areas requiring groundwater protection. Satellite imagery of moderate resolution, such as Landsat EMT+, allows the frequent updating of land use maps and repeat modeling of risk factors.